This telescope is 2.5 feet long. How do I know? I use a tape measure. I was just looking at the Andromeda Galaxy. It's 2.5 million light years from Earth. How do we know? Certainly not a tape measure. Here, let's talk about interstellar distances. To determine the distance to nearby stars, astronomers use parallax, the effect where an object seems to change position depending on where it's viewed from. We humans use it every day, using our two eyes. Notice how from my perspective, the tractor seems to change position while the background remains still. The same concept can be used with stars. Using telescopes, we take a picture of the star, and then we take another picture of the star 6 months later, when the Earth is at the other end of its orbit. By measuring this change in the star's apparent position, while keeping the background stars stationary, we can triangulate the distance to the object. While this method works for stars that are relatively close, most stars are simply too far away for the apparent change in position to be measurable. Farther out, the methods of finding distance all revolve around the concept of the standard candle. Standard candle doesn't refer to an actual candle. It refers to an astronomical object that has a known luminosity. When it's close to me, this candle's actually pretty bright. However, when it's moved away from me, it gets significantly dimmer. In fact, the brightness of an object decreases with the square of the distance. And while it looks dim to me, I know that it's producing the same amount of light that it did before. It has the same luminosity. So by knowing the luminosity of an object and its apparent brightness, we can determine the distance to it. The catch here is that we need to know the luminosity of the object, and the method of determining the luminosity depends on the object in question. For example, Cepheid variable stars periodically change in luminosity. Their luminosity at any given time can be determined by the period of their oscillation. For other stars, we can determine their luminosity simply by observing the spectrum of light they produce, and comparing this to the spectrum of stars of a known luminosity. Using the appropriate method, we can approximate the distance to virtually any object in the universe. Measuring interstellar distances may not be as glamorous as some other topics in astronomy, but it certainly is one of the most important. Without it, we would have never discovered dark energy and the accelerating expansion of the cosmos. Evidence for theories regarding everything from the Big Bang to quasars would be far less concrete. Being able to accurately determine astronomical distances has played a fundamental role in our understanding of the size and structure of the cosmos.